Right here, for example, I would get a compiler error, actually maybe a couple of compiler errors, because over here I declared a function which takes three types of variables, one integer, one float, one character. It's called the func and it returns void, but in my definition I only have it's called the func, it returns void, and I only have one variable right over here. So the compiler will think that this is a different function altogether because I didn't give it enough variables over here, and the compiler is going to wonder where is the definition of this function over here that we declared. So make sure your declarations and definitions match. They don't have to match in the names of variables that are being passed. As you see over here, this is called an integer, and over here it's called y, but they must match in the type of return value, the name, the amount of variables. Over here we have three variables, one over here, and one over here, and whatever types of variables they are. This is integer, this is float, and this is character in the correct order. Only then will the compiler recognize this as a declaration of a function so that we know that it exists, and this as the definition, the explanation of that function that we declared earlier. So now we know how to pass variables that we already created into different functions so that those different functions could do stuff with these variables, so that now the different worlds, the different levels of scope don't have to be entirely separated, and we could apparently call a different world, a different function, to help us out with variables from our world, from where we are now, our current scope. However, the truth is that the problem is not entirely solved. Try it out for yourself. Let's see. Here I create three variables. X has 9, my float has 2.345, and my character has the A character. And then we're going to go ahead and print out those three variables to the screen. First X, then a space, then my float, then another space, and then my char, and then end of the line. So of course we're going to see 9, and then a space, and then 2, 3, 4, 5, then a space, and then the A character. Now we go into the func and we pass all these three variables, X, my float, and my char. So let's see what happens over there. Here we are in the func. We are passing those three variables, but in our function it's going to be called y, my1, and the letter. So let's see if we really got our three variables. Let's try to print them out as well. Here we go, we are printing out y, space, my1, then a space, and then letter, end of the line. Let's see if so far everything works. Let's run the program. Here we go, everything's okay. In the main function we printed it out and it worked good. 9, 2, 3, 4, 5, and A. And then in my func everything also printed out well. 9, 2, 3, 4, 5, and then A. Now in the func, let's try to change the variables around. Let's say y, which is really x, equals 5. My 1, which is really my float, equals 5.432. And then letter, which is really my char, will be x. To make sure that they actually change, let's print all the stuff out again to see that everything actually changed when we were in the func. Now the function is finished. Let's go back to main where we came from, and let's make sure that the variables are still changed. So we're going to print them out again, but again with their original real names that they got when they were in main. Cout x, my float, and my char. You understand what's going on? We're creating the variables, printing them out, passing them to the function, which also prints them out, changes their values, prints out the new changed values, and then back in the main function we're going to print out the same thing again. So let's see if everything works well. Let's run the function. Here is our program. 9.2345a checks out. That's what we printed out over here in the main function. Next, again, 92345a is what we first printed out when we called the func right over here. Then 5, 54322, and x is what we changed it right over here in the function. and we printed it out right over here. And then what happened is the function finished, we got back to main, and we printed it all out again. Let's see if it actually did. Oops. 9, 2, 3, 4, 5, and 8. It looks that like the variables weren't even changed. But I thought we passed them into the function which changed their variables, and we even proved that they changed the variables because we printed it all out and it was actually changed, as we saw in the last line, 5, 5, 4, 3, 2, and x. So what happened from the function when it came back to main that everything changed back to the way it was originally? That's weird. Well, again, this all has to do with the rules of scope. The main function has his own world with his own variables, and the func has his own world with his own variables. When I pass variables from the main function world to this function world, the actual original variables are not being passed over. When I pass, for example, x into the func, what really happens is x stays in the main function, and a copy of x, a new integer copy of x, is created for the world of this function over here. So yes, the program does do us a little favor by giving us a correct copy of the x variable, because right now in this function we have a perfect copy of whatever x was, because we have the actual y over here, which as we see prints the same number that x had over here. It's all 9. But unfortunately, it's only a copy. So whatever you do in this world of the function will only happen upon this variable copy, which we have in our world over here. Once the function is finished, all of its variables and everything you passed to it, all the copies that were passed to it, get all destroyed, and whatever happened to them makes no difference anymore. And back in main, we already have our original x, my float, and my char. This is known as passing by value. When you pass a variable, meaning you're passing the variable itself into that function, then the variable itself is not being passed, only a copy of that variable is being passed. So we have two integers existing right now, one in the main function and one in this function over here. It just so happens to be that they have the same value, they have the same number, because it's a perfect copy. But it's only a copy, it's not the original. So we know how to pass variables into a function so that the function could do some useful stuff with the variables. But how do we get our results back from the function? If all the function does is create its own little copies, how do we get our desired results back from the function if everything in that function gets destroyed? One way of doing this, as we learned, is to use return values. Make sure that your function will return a number and just return the results that you'd like from that function. For example, if you want to return the number 5 from y, all you have to do right now is return y, and right now this function, before destroying everything that it has in its own little world, will first return the value of y to whoever called the function. So we could take advantage of that and use the return value as an expression to be put into the variable x, for example, as we learned about returning variables, values. Well, alright, that's already useful because we could get back results from a function that does something, but it's a shame we only could get back one single result at a time. What if I want to get 3 results, like changing all of these 3 variables and not only returning the variable y? As we learned, it's not possible to return many things because after the first time you hit return, everything after that is ignored. So you could only return one thing at a time from a function. Well, we're going to learn other techniques later on in different videos. For now, let's just play around and enjoy the power of being able to pass variables into functions and then even get a result back from that function, just one single result at a time. As we see, as the program is running right over here, that in the end, not all 3 variables were changed, but at least the first one, the integer x, was changed thanks to the return value from the function.